Welcome to our MOOC Technical Drawing for Mechanical Engineering. Let's start with Module 2, Unit 3. Module 2 is frequently used standardized part, and Unit 3 we are going to talk about gears. A gear is a rotating machine part having cut teeth. These teeth mesh with other tooth part. The simplest example of a gear train has two gears. The input gear, also known as drive gear, transmits power to output gear, which is the driven gear. The small gear rotates at higher speed than the big gear. The ratio depends on the sizes of the wheels, that's it, diameter and number of teeth. There are several types of gears. The most common are the spur gears, the wheels have parallel axes, and as you can see, the teeth are parallel to the wheel axis. Helical gears. The axes can be parallel or perpendicular axis, and the teeth have an helix shape. A start worm and wheel. It is a special kind of helical gear, but worm helix angle is close to 90 degrees. And bevel gears. It is shaped like a right circular cone. When two bevel gears mesh, their imaginary vertices must occupy the same point. We will see this in another drawing. Gears have an isostandard simplified representation. A real representation would make the assembly and each wheel drawing unclear. Each wheel drawing must also include mandatory dimensions for its manufacturing. Spur gears. Although in this figure you can see the drive gear is the smallest, it can be the opposite, depending if the speed is reduced or increased. This is the representation for the train gear. The thin, long chain line represents the pitch circles. They must be tangent. And see in the figure on your right below that we don't hatch the teeth from the wheel. Now, if we represent each wheel, we must dimension the addendum circle. This is mandatory. You can see here the dimension. This is the external dimension of the wheel. We must dimension the external shape of our wheel. The diameter for the addendum circle must be calculated with the corresponding formula for spur gears. The pitch circle mustn't be dimensioned, only drawn. We will leave these formulas as the information in our module. Helical gears. The representation is similar than spur gears, except for three thin lines indicating the helical sense. So this is helix right sense and left sense. As in spur gears, the external form of the wheel must be dimensioned. The diameter for the addendum circle must be calculated with corresponding formula, which will be available for you in our information in the module. If the gear is machined on a shaft, the needed dimensions are similar as if it's a wheel on its own. A start worm and wheel. It is a special type of helical gear. The axes are perpendicular. And the most common type of gear is with a concave teeth for the wheel. It is easy to recognize in a drawing when we have this type of gears because of the peculiar shape of the wheel. In this figure, we can see the dimensions that should be calculated with the formulas. Of course, all other dimensions must be given to completely define the wheel. A start worm is dimensioned like an helix gear. Once again, you will have these formulas available in the information in our module. In this case, the sense of the helix worm is left, so the wheel must also be left. But be careful, to know the sense of the worm must be positioned vertically. So you can see the helix is left. Bevel gears. In an assembly plane, the two pitch cones, which should be tangent, must be represented, and the imaginary vertex. Once again, you see the teeth are not hatched. The gear must have these dimensions. The dimensions in red have the corresponding formula. So this is the end of Unit 3, Module 1. In our summary, what have we learned? Spur gears are represented with the external shape. In assembly or part drawing, the pitch cylinder is represented with a long, thin chain line. In assembly, pitch cylinders are tangent. In the part drawing, dimensions define the external measures of the gear. External diameter must be calculated. Helix gears are represented in a similar way and include 3 lines which indicate the sense of their helix. Worm and gear wheel is a type of helix gear with special properties. In this case, the gear wheel can have a special shape for the concave teeth and has some special dimensions in the drawing. Bevel gears have a cone shape. In the assembly drawing, the pitch cones are represented with long chain line. The drawing for each gear defines the external dimensions. Some of them must be calculated with the corresponding formulas, which will be available for you. So after our summary, we will be waiting for you in Module 3.